Good morning everyone, I'm Erwin Emma Tunan and I'm going to report about inventory models in production and operations management. Models are used to assess the amount and type of inventory that an organization needs to hold. These are based on the amount of product that will be required from the operation and the inputs required in order to produce it. So first, we have fixed order quantity models. These need to determine when and how much to order, which include basic economic order quantity, production order quantity, and quantity discount model. Before I discuss those models, I have here key inventory terms. The lead time. This is the time interval between ordering and receiving the order. Holding or carrying costs. These costs are to carry an item in inventory for a length of time, usually a year. It may be heat, light, rent, security, deterioration, spoilage, breakage, depreciation, opportunity cost, etc. Ordering costs. These are costs of ordering and receiving inventory, like shipping cost, preparing invoices, cost of inspecting goods upon arrival for quality and quantity, moving the goods to temporary storage. The setup cost. This is the cost to prepare a machine or process for manufacturing an order. And shortage cost. Cost when demand exceeds supply. The opportunity cost of not making a sale. Now, let's talk about basic EOQ model or economic order quantity model. This model has important assumptions. First, demand is known, constant and independent. Second, the lead time is known and constant also. Third, receipt of inventory is instantaneous and complete. Fourth, the quantity discounts are not possible. Fifth, only variable costs are ordering and holding. Sixth, stockouts can be completely avoided. In this figure of inventory usage over time, I just want to demonstrate how would we use inventory over time. A quantity Q over time will use as a constant depending on what the demand rate is. And so, let's say for example, our quantity Q is 100 and we use 10 units per day. Then if we use constant of 10 units per day, then this period right here, the time would be 10 days. So therefore, our cycle time is 10 days. So every 10 days, we will consume the order quantity which is 100, alright? And this will continues over and over again. So receive items here, and as we receive, we will use the same usage rate. But of course, we need to place an order for the item when the order arrived to the order point. And the average inventory on hand is Q over 2. So why Q over 2? If we put another triangle here, we can form a rectangle. So we all know in calculating an area of rectangle, we have the formula of length times width, while in triangle, we have the base times height. So that's why average inventory on hand is basically Q over 2. Another figure of inventory cycle to understand more, this is the Q or the quantity on hand, maximum inventory, and the reorder point, which is the minimum unit quantity that a business should have available inventory before they need to reorder more product. And this is the lead time, where the time interval of ordering and receiving the order. Here we go now to the EOQ model. The objective of this model is to minimize total cost. We have here the holding cost, which is the cost to carry an item to inventory for a length of time, and the setup cost, which is the cost to prepare a machine or process for manufacturing an order. So always remember that these two have always negative relationship. As the holding cost increases, the setup cost decreases. That's why we need to calculate the total cost of holding and setup to know the minimum total cost, which is the optimal order quantity or the economic order quantity. Now, let's proceed to calculate the annual setup cost. Given that the Q is the order quantity, the Q star is the optimal number of pieces per order or EOQ, and the T is the annual demand in units for the inventory item, S is for the setup or ordering cost for each order, H is for holding or carrying cost per unit per year. So the formula is the number of orders placed per year times setup or order cost per order. Annual demand over order quantity times setup or order cost per order. Therefore, the formula here is D over Q times S. While the annual holding cost formula formed by the average inventory level times holding cost per unit per year. Order quantity over 2 times holding cost per unit per year. So therefore, we have the annual holding cost formula of Q over 2 times H. Furthermore, the optimal order quantity or EOQ is found when annual setup cost equals annual holding cost, or we take the derivative of the total cost function and set the derivative or slope equal to 0 and solve for Q. So in solving for Q star, we have the formula of square root of 2 times D times S over H. We have here an EOQ example, and the given data for order quantity units per year is 1,000, and the setup cost per order is $10, and the holding cost per unit per year is $0.50. So in calculating the Q star or EOQ, we have the formula of square root of 2 times D times S over H. So square root of 2 times 1,000 times 10 over 0.50 is equal to square root of 40,000. Then the square root of 40,000 is equal to 200 units. So now we already determined the optimal order quantity, which is 200 units. So now let's find out the expected number of orders. The formula here is demand over quantity, or D over Q star. So 1,000 over 200 is equal to 5 orders per year. We also then to calculate the number of orders per year, which is 5, and now we will proceed to the calculating of expected time between orders, where we have the formula of number of working days per year over N. So we assume that we have 250 days of working in a year, and 250 over 5 is equals to 50. Therefore, 50 days between orders. We will now solve for the total annual cost. So the addition of setup cost and holding cost will be the formula here, where TC is equal to D over Q times S plus Q over 2 times H. TC is equal to 1,000 over 200 times 10. The answer will be $50, and 200 over 2, or 200 divided by 2 times 0.50, the answer will be $50. Then the addition of the setup cost and holding cost will be the total annual cost, which is the $100. The EOQ is considered as robust model. The reason why it is considered as robust model because the total cost curve is relatively flat in the area of the EOQ. Going back to the EOQ model that I presented to you earlier, so the holding cost and the setup cost, the addition of these two curves will be the total cost. So we will find the optimum quantity between the intersection of the holding cost and setup. cost right here. So this is the optimal order quantity as I've said earlier. Let's proceed now to the production order quantity model or the POQ model. So the assumption here first is the receipt of inventory is not instantaneous and complete. Second, units are produced and used or sold simultaneously. Third, production is done in batches or lots. Fourth, capacity to produce a part exceeds the part's usage or demand rate. And fifth, hence inventory builds up over a period of time after an order is placed. So the production order quantity model is used in production environments to determine how much inventory will be produced based on the economic order quantity and the demand for the product. For example, the economic order quantity might be 15 products and the customer demand might be 5 per day, which might mean that every 3 days, 15 products will be made. Before we compute the optimal number or the optimal quantity of production order quantity model, the holding cost will be modified here where it is equal to maximum inventory level over 2 or divided by 2 where H is equal to Q over 2 times 1 minus T over P times H. We have here the simplified formula of production order quantity model or the optimal quantity of production order where the holding cost is modified. So the formula is square root of 2 times ds over H times 1 minus D over P. Let's have an example. We have here the given data where D is 1,000 units, setup cost $10, holding cost is $0.50 per unit per year. The daily production rate is 8 units per day and the daily demand or usage rate is 4 units per day. The number of days plant is open for 250 working days. So let's now solve for the Q star. Square root of 2 times 1,000 times 10 divided by 0.50 times 1 minus 4 divided by 8 is equal to square root of 80,000 where the square root of 80,000 is 282.8 or 283 units. To summarize, quantity discount models are used where the price of the item ordered varies with the order size. Reduced prices are often available when larger quantities are ordered. The buyer must weigh the potential benefits of reduced purchase price and fewer orders that will result from buying in large quantities against the increase in carrying costs caused by higher average inventories. Hence, there is trade-off between reduced purchasing and ordering costs and increased holding cost. So let's move on to the total cost with purchasing cost. The formula of calculating the total cost with purchasing cost is the addition of the three, which is the annual carrying cost plus annual ordering cost plus purchasing cost, where P is the unit price. Remember that the basic EOQ models does not take into consideration the purchasing cost because this model works under the assumption of no quantity discounts. Price per unit is the same for all order size. Note that including purchasing cost would merely increase the total cost by the amount P times the demand or D. This is an example of total cost with constant carrying cost. In this case, there is a single minimum point where all curves will have their minimum point at the same quantity. On the other hand, total cost with a varying carrying cost is expressed as a percentage of the unit price. Each curve will have different minimum point. We will now proceed to the quantity discount model. This is an example of quantity discount schedule inventory where it has discount number 1, 2, and 3. In discount number 1, the discount quantity ranges only to 0 to 999 with no discount and with the discount price of $5, while in discount number 2, it ranges to 1,000 to 1,999 with 4% discount and discount price of $4.80. And last, the discount number 3 ranges to 2,000 and over with discount of 5% and discount price of $4.75. Many suppliers offer discounts for ordering higher quantities of inventories items. This model balances the benefits of ordering higher volumes of inventory with the cost of holding it. So, the only feasible here is the discount number 1 because it reaches its own discount range, which is 0 to 999 discount number or discount quantity. Because the Q star for discount number 2 is below the allowable range at a point A and must be adjusted upward to 1,000 units at point B. Another example of quantity discount. So here, choose the price and quantity that gives the lowest total cost. Buy 1,000 units at $4.80 per unit. Reorder point curve. So the economic order quantity model supports decisions on how much to order. The reorder point model is used to decide when to order inventory and is based on the time that it takes for the inventory to be received from the time that the order is placed, with the objective of minimizing excess inventory and having sufficient inventory on hand to meet production requirements. Probabilistic models to determine safety stock and reorder point. So these are models that are designed to take into account variability in the demand for a product, and they assess the amount of inventory that will be needed based on past demand variability to maintain a desired level of service. Safety stock is held to do this. Other probabilistic models are used when data on expected demand is weak. Safety stock is used where there is less stability. It is defined as the amount of inventory held in addition to the expected demand for that inventory. Many approaches are used to determine the level of safety stock. Other models use probability to estimate the safety stock needed. So let's move on to another model, which is the single period inventory model. It is used to handle ordering of perishables. That's why it is single period, like fresh fruits, flowers, and other items with limited useful lives, newspaper, spare parts for specialized equipment. In a single period inventory model, items are received in the beginning of a period and sold during the same period. The unsold items are not carried over the next period. The unsold items may be a total waste or sold at a reduced price, or returned to the producer at some price less than the original purchase price. The revenue generated by the unsold item is called the salvage value. Fixed period systems or P systems. Order placed at the end of a fixed period. Inventory counted only at the end of period. Order brings inventory up to the target level. Only relevant costs are ordering and holding. Lead times are known and constant, and the items are independent of one another. Fixed period systems, also called periodic review system. So the previous models are used to determine how much should be ordered whenever an order is placed. Fixed period systems are based on ordering for a fixed period. For example, on the same day each week, orders are placed to raise the inventory to a predetermined level based on ordering and holding costs and order lead times. Fixed period systems have these assumptions where inventory is only counted at each review period, may be scheduled at convenient times, appropriate in routine situations, may result in stockouts between periods, and may require increased safety stock. So that all covers it. Thank you.